Welcome. We'll be going through our right triangle study guide for Unit 10 in geometry, going over Pythagorean theorem, special right triangles, and trigonometry. The first section of questions here asks us to identify if the side lengths provided can form a right triangle, acute triangle, or obtuse triangle for us. So, in order to do that, we're going to need to make sure that we know what kind of side lengths we have available to work with the converse of the Pythagorean theorem. So we want to identify the smallest and the medium measurements. So 9 and 7 are the small and the medium, and we're going to square those and add them together to compare with the largest measurement that you have. And so checking out that arithmetic, 9 squared plus 7 squared then gives us 130 in comparison to 12 squared, that is 144. 130 is less than 144, so that makes this an obtuse triangle. Across the page to that number 2, looking at the small and the medium measurements here, 8 squared plus 12 squared gets compared with the largest measurement, that's 19 squared there. And so with that arithmetic then, let's see, 8 squared plus a 12 squared for us puts us at 208 on the left side, comparing with 19 squared is 361. So 208 is less than that 361. A less than symbol when we set it up tells us that this is an obtuse triangle. Then in number 3, looking at this, so I have 1, 1, and the square root of 2. Well, if you're not sure which one is the smallest or the largest, we have to check out what is the square root of 2. So it does have a decimal value of 1.4, which is going to be larger than 1. So 1 and 1 would then be my small and my medium. 1 squared plus 1 squared gets compared with the square root of 2 squared. So 1 squared plus 1 squared, 1 plus 1 makes 2. And we're comparing this with the square root of 2 squared. And so hopefully you remember that a square root and a square are inverses to cancel each other out. We're looking at that compared to now 2. So 2 is equal to 2. This would give us a right triangle. When I look over at the number 4, 12 is my smallest and 30 is my medium. So those will have to be the two that I square and add together in comparison with 31 squared. All right, so let's see, we've got the 12 squared in there, adding on the 30 squared. We're talking about 1,044 compared with, and then 31 squared is our other item, 961. So 1,044 is greater than 961, and that greater than item gives me an acute triangle with those 3 lengths. I'll find my small measurement 10 and my medium measurement 24 coming out of problem number 5. So I need to think 10 squared plus 24 squared. Compare that with 26 squared. And go ahead to put those into your calculator if you need to, certainly. So 676 gets compared with, and we'll see, 676 out of that 26 squared. These two values are equal to each other. That means that we have a right triangle. There's certainly going to be a 90-degree angle in that formation. When I look at that number 6, there's lots of different number formats here. So again, I need to figure out which is the small or the medium or the largest of these options. So 12.2, I can figure out, can see that pretty easily. So I need to know what 70/3 is. This is about 23.3. And I would also need to know what the square root of 650 is. That's about 25.5 if I round that. So I would then say that 12.2 and 23.3 are my smallest two values. So 12.2 needs to be squared and 70/3 needs to be squared. Notice I'm going to go back to those original formats so that I don't have any rounding errors to deal with, comparing that to the square root of 650 squared. So I'm going to put those in and certainly find out what we have. So 12.2 needs to be squared. And then also, let's see, the fraction of 70/3 needs to be squared. And so I'm looking at 693.3 out of that. Compare this to 650, the square root of 650 that gets squared. And again, I notice that an exponent 2 and a square root are inverses to cancel each other out, so I end up with just 650. So 693 then is greater than 650. That's going to give me an acute triangle from that formation. So as we move down to the next section, find the values for the missing variables. Notice with each of these, you're going to need to identify what type of problem, what method you would use to set these up and work through them. So in number 7, I am given 2 sides, needing to find the third side. This is going to be a Pythagorean style problem. So my leg squared plus my leg squared has to equal my hypotenuse squared. That's 8 squared plus 15 squared then to equal our x squared. We'll type that information into the calculator. I've got 289 is equal to x squared. Remember then, we're going to go ahead and take the square root on both sides so that I can cancel that exponent. And the square root of 289, well, hopefully you know that that's a perfect square, but if you didn't recognize it, you can certainly type that in to find out that 17 is the value for x. When we look over here at number 8, I can see that I'm given a side and an angle and looking for a side. When I look at that angle, I notice it's a 45-degree angle. So I know that I have a 45, 45, 90 triangle. This is going to be special right triangle patterns. So I know that my 2 legs are congruent. Both of them would have to be x and x, with my hypotenuse given as a 13. So to go from the hypotenuse to a smaller leg, I'm going to divide by the square root of 2. So you're thinking, what is 13 divided by the square root of 2? We need to rationalize that denominator, multiply by a square root of 2 over a square root of 2. So this will then give us, let's see, 13 square root of 2 across the numerator and 2 across the denominator. There's my value for x. As I look at question number 9, I can see that I am given 2 sides. I am looking for the angle measurement. This is going to be an inverse trig problem to find the angle measurement. So from my reference angle that I'm looking for, I look across and I see that 18 is my opposite. I see that 12 is my adjacent leg. I do not have anything labeled there on the hypotenuse. With an opposite and an adjacent, I'm going to be setting up a tangent problem. Tangent of the angle is equal to opposite over adjacent. So in this case, that's tangent of x. That's equal to 18 over 12. So when you do a trigonometry problem, remember that you need to make sure you're talking in the right mode or in the right language. Use that little wrench icon to get into your settings and confirm that you are on degrees. If we're talking about an angle measurement in degrees, we have to use degrees in our calculator. Then to find an inverse, we are going to go into the settings panel from my keypad, use the functions. Trig is that tab. All the inverse functions are in the center row. So I want inverse tangent. That'll bring it up as a tangent of -1. Type in that fraction, 18 over 12. I'm now talking about an angle that is approximately 56.3 degrees. We'll go ahead to the question number 10. I'm given a side, looking for a side, given an angle, and I do notice that that angle is 30 degrees, so then I know that I have a 30, 60, 90 triangle. That's going to clue me in to use those special right triangle patterns. So the side across from the 30-degree angle is always where I put my star. That's the most important side. If I have it, I'm good to go. If I don't, that's the first thing that I want to find. I know the hypotenuse and need to get back to that star side that's across from the 30. I have to divide by 2. This is going to be half the length. That'll put me at 5. Once I know that side with a star, to get to the longer leg across from 60, remember we're going to multiply by the square root of 3. So x is 5 times the square root of 3 for us. I'll look into the number 11 then. Here I am given a side, given an angle, looking for a side. This would clue me in that we're using trigonometry. So from my reference angle, label what we have. Across from that, I have my opposite side, and then I also have my adjacent leg given. So with an opposite and an adjacent, recognize that we are setting up a tangent problem. So tangent of the reference angle 20 is equal to opposite over adjacent. That's x over 7 here. Anytime that I have a number in the angle, I put it over a number 1 so that we can cross multiply. X times 1 is x. And then from the other side of my equals, I'll do the tangent of 20 that's being multiplied by 7. That simply needs to go into your calculator, tangent of 20. And then we are going to multiply this by 7. But do be aware, you can see now I've got a negative number coming out. What's this telling me about? Well, the issue here is we can't have a negative side length. But if I have my tangent of 20 specifically, right? I want to make sure that I communicate to the calculator I'm taking the tangent just of the 20 degrees. That's going to be my function. Then I multiply it by 7. That will set this off correctly for us. So x is then 2.55, we would say, if we round that off. Over to number 12 then. I am given a side, given a second side, looking for a side length. Hopefully this clues you in that you want to do some Pythagorean theorem there with that. So a leg squared plus a leg squared has to equal a hypotenuse squared. Some of you might be recognizing that this is a Pythagorean triple and solving right away. If you don't, by all means, continue with the algebra. X squared plus 64 is equal to 100. You've got to subtract that 64 from both sides, so x squared would be equal to 36. And when you go ahead to take the square root on both sides, you'll come to the conclusion that x is equal to 6. So if we flip on over then to that next page, continuing on our way, I see in number 13 here, we are given a side, given a second side, looking for a side. This should clue you in that you want to do a Pythagorean theorem for it. So a leg squared plus a leg squared has to equal the hypotenuse squared. 4 squared plus x squared equals 19 squared then. So I'm looking at 16 plus x squared equals, and 19 squared would be 361. Subtract that 16 constant from each side. Let's see, what do we get out of that? 361 minus 16 puts us at 345. We'll go ahead and take the square root on both sides so that we can cancel that square root with, so we can cancel the square with our square root. Excuse me, I got a little tongue-tied there. And so 345 is not a perfect square, as you'll see when you get a decimal answer coming out for it. So we're going to have to focus on making that into simplest radical form. Let's think about a factor tree for that. 345 is divisible by 5, so I could go with 5 times 69. And let's see then, 69 is divisible by 3. So we could get 3 times 23. Now we have all primes here, nothing else that can make a pair, so we do end up at the square root of 345 for my x value. In this number 14, I'm given a side, given an angle, looking for a side. My angle is 46 degrees. That's not a special one. So to find a side, I'm going to use trigonometry. From my reference angle, I'm going to label an opposite side, and I'm going to label a hypotenuse. And look at that, with an O and an H given to us, recognize that this is going to be a sine problem. So the sine of my angle 46 equals x over 18 here for us. Number in the angle, put it over a number 1, and we cross multiply. X times 1 is x, and sine of 46 gets multiplied by 18. And so again, remember when we come over here to type that into the calculator, remember that little item that we ran into last time. We've got to put that angle into the parentheses so the calculator knows exactly what we're taking the sine of. So it's sine of 46. Then we multiply it by our 18. So that tells me x is 12.95 if we round there. Question number 15, I'm given a side, looking for 2 other sides with a 30-degree angle there. So I know it's a 30, 60, 90 triangle. With my hypotenuse given to me, the first thing I want to find is that side across from the 30-degree angle. So given the hypotenuse, to get to that side across from 30, I'm going to find y first. We need to divide by 2 to get half the length. So 28 square root of 3 divided by 2, we're going to divide out the fraction and simplify that. So this comes up as 14 square root of 3 for us. That's my y value. Once I know that, to get to the long leg that's across from 60, we multiply by the square root of 3. So let's see, 14 square root of 3 gets multiplied by the square root of 3. So that's 14 times the square root of 9, because values under radicals can multiply with other values under radicals. Hopefully you noticed that the square root of 9 is a perfect square. So you're actually looking at 14 times 3. That's going to give you 42 to be your x value. Now in this question number 16, we're going to solve for x and y. And there's a lot going on here in this picture. So for me to begin, I'm going to focus on the triangle that I have on the right because I can see that I've got two angles and a given side length. So I can use this to help me find the vertical measurement. Maybe I'll call that z. And I'm going to use this. Why do I need this z even though it wasn't asked for? That's going to be my transition to help me move from the right triangle to the left triangle when I'm going to need to get to x. I'll need some side length given to get to x. So we'll find that z in the meantime. We do have a 30, 60, 90 triangle. So z is my star value that would be important. 34 is that hypotenuse. I'm going to have to divide by 2. So that would tell me that z is 17 for us. Knowing that, I'll also go ahead and use this value to find out the bottom side of that right triangle here. If I put some scribbles over it instead of making it a smooth line, maybe we'll find that as a variable w. So with that, go ahead and remember that the side with the star, to get to that long leg that's across from 60, we're going to have to multiply by the square root of 3. So I'll be looking at 17 times the square root of 3 for my w value. So we found a couple of pieces there. Now to continue on with what we're asked, I'll start focusing on the left triangle. I'll trace that in a darker blue. It is a 45, 45, 90 triangle. So because I have those two congruent angles of the 45 and 45, I must also have the two congruent sides as the two congruent legs. So if I just found z as a 17, then I know that the bottom side is also going to be the same congruent measurement of 17. Use that to get to your x. Either leg to get to the hypotenuse in a 45, 45, 90 is going to multiply by the square root of 2. So we're talking about 17 times the square root of 2 for that x value. So that answers one question for us. Leave x in simplest radical form. Just found that as 17 square root of 2. But remember now, it did want us to find y and said that y could be in decimal form because y was all of this together. So y has to incorporate the 17 and the 17 square root of 3 that we did. So if we were leaving that in radical form, this would be our answer because a constant can't be added to something with a radical. But to make that into a decimal, certainly we can just go ahead and ask the calculator for that. So y would be approximately 46.44. As we move on down then to 17, we're going to find the value of w and then find x. So again, there's a lot going on in this picture. We're going to need to isolate little bits at a time. I'll begin with this triangle that I now have outlined in pink. 42 is my reference angle given a side, and I'm looking for a side w. So from that 42, I see an opposite and I have an adjacent leg. This is going to be using a tangent. So the tangent of my reference angle 42 is equal to 12 over w. Number in the angle, put it over a number 1, We cross multiply. 12 times 1 is 12. Tangent of 42 times w then for us. Notice that you'll have to divide by your trig function in order to undo that multiplication. This is almost like a coefficient for us. So anything divided by itself cancels, leaving w behind. I just need to know what is 12 divided by the tangent of 42. And that puts us with w value at 13.33 when we round to the nearest hundredth. Then the question says to go on and then find x. So x is part of this other triangle here, if I go ahead and trace it in green. But notice actually the whole bottom of this triangle encompasses all of this area. So I'm going to go ahead and label it y. So when I work with this green triangle, I'm actually going to be solving for y, reference angle of 27. My 12 is my opposite side, and y is the adjacent side to that reference angle. So this is, again, a tangent problem. Now, tangent of 27 in this case is equal to 12 over y. Number in the angle, put it over a number 1 so we can cross multiply. 12 times 1 is 12. Tangent of 27 times y. We're going to divide by that tangent of 27 so that I can cancel it to isolate y. And what I divide on one side, I have to divide on the other side, of course. So let's find out what is 12 divided by the tangent of 27. We are looking at 23.55 for that y value. Now, how does that help us get to the x that we are asked for? Well, notice x is only a portion of that. To find x, we've got to take y and subtract the w value. So my y value as a 23.55 needs to subtract that w that we solved for as a 13.33. And so that's giving us x as, whoops, I'm not going to be able to see that there if I write on top of those directions for the next one. We'll move it over this way. So 23.55 minus the 13.33 puts us at 10.22 units for that x. Right? So that was definitely a multi-step problem for us again. Then number 18, asking you to write a tangent ratio for your angle P. So a tangent for angle P, focusing on P as my reference angle. I'll label the opposite side and the adjacent side to get that tangent. So tangent of P is equal to my opposite of 20 over my adjacent of 15. Some people will leave their ratio like this, or some will also notice that that can be simplified. Both parts of the fraction have a common factor of 5, so we could also write that as 4/3. The sine ratio for angle Q is also asked about here. So if angle Q is my reference angle and I'm looking for a sine, from Q I need the opposite and the hypotenuse. So the sine of Q would be an opposite of 15 over a hypotenuse of 25. Again, some people will leave the ratio as is because these are the values in the triangle. Other people would notice the common factors that you can divide out of a 5 and leave it as 3/5. And so then in 19, we move on to talk about Viola. And we start out here driving 170 meters up a hill. So let's draw a sketch of what she's got going on here. Here's my right triangle, driving 170 meters up a hill, and it makes an angle of 6 degrees with the horizontal. So my hillside and the hillside and horizontal have an angle of 6 degrees. What's the length of the horizontal distance for us? Hope that you recognize in that we are given a side, given an angle, looking for a side. So that's going to certainly be a trigonometry problem for us. From that reference angle of 6, we have an adjacent side and we have a hypotenuse side. That's going to indicate a cosine is coming into play. So cosine of my angle 6 degrees equals an adjacent x over a hypotenuse of 170. Number in the angle, put it over a number 1, cross multiply for us, x times 1 is x, and then you're doing a cosine of 6 times 170 to get that final answer for us. And so let's see, the cosine of 6 and it gets multiplied by 170. So x must be about 169.07 meters for us, right? And that makes sense for this horizontal distance to be pretty close to the hypotenuse because my angle of 6 degrees is so shallow. On to the next page here with that number 20. At 2 p.m., the shadow from a lighthouse is 22 feet long. So we're going to have to draw out our sketch. Let's get a lighthouse here. And the shadow that is 22 feet long. The angle of elevation from that shadow, right, up to the top of the lighthouse is 72 degrees. Find the height of the lighthouse for us. So from that reference angle, I see that I have, we're going to assume, of course, that the lighthouse and the ground make a right angle, that it's all standing perpendicular. So from the 72, I have the opposite side at my lighthouse, and I have the adjacent side at my 22. This is cluing us in then that we'll be using a tangent function. So this is a tangent of 72. That's equal to my h over 22 for us. Number in the angle, put it over a number 1, cross multiply. 1 times h is h. And then we're going to do the tangent of 72 times 22. And for all of that, go to your calculator to get some trig function. So the tangent of 72 gets multiplied by 22. We are looking at 67.71 feet for the height of this lighthouse. That next question asks us to now find the area of the triangle. Area of a triangle is that 1/2 base times height. And remember that the base and the height always need to have a right angle in between them. So the base is given to us as 10 centimeters. Our job is to find the height, and that has to be this dashed line because that's the one that's perpendicular to the base. So we will need to focus then on a right triangle within there. We're given a hypotenuse of 6 centimeters. We know this other side here that I've indicated with the scribbles, it's not 10 centimeters, that's the whole length, but that would be half of it, right? We'd split that into a 5 and a 5. Since we have those congruent 6s, the 10 would also have to be split into 2 congruent pieces. So we need to find that measurement of h. So let's see. 5 squared plus h squared equals 6 squared. Go through that Pythagorean theorem then for us. 25 plus h squared equals 36. Subtract the 25 from each side. Sounds like h squared is equal to 11. And when we go ahead to take the square root on both sides, okay, so h is the square root of 11 because that's a prime number. Can't make a factor tree to go into simplest radical form. So when we go ahead then to find that area, so this is 1/2 times my base of 10 times my height of square root of 11. So 1/2 times 10 is 5 times the square root of 11. There's the area for our triangle. This is then 5 square roots of 11, and that's going to be in square centimeters for the units. Number 22 asks for the length of an altitude in an equilateral triangle. So first of all, let's draw this equilateral triangle where I have all 3 side lengths the same. Side lengths are all 8 square root of 3. And we're looking for the altitude. If you don't remember, the altitude then comes from the vertex and meets the base at a right angle. So this is the altitude that I want to find. I'll label that as an A. Using that, focus on a right triangle that you have. And in this right triangle, we're going to need to find out what one of those sides is. Now we knew that the entire bottom was 8 square root of 3. This is only half of it. So in orange here, we're talking about 4 square roots of 3. Also, hopefully you could pick up on that as well, because if this was an equilateral triangle, all of my angles would have been 60 degrees, meaning that that triangle I highlighted in yellow is a 30, 60, 90 triangle for us. So if you have a little bit too much going on in that picture right now, let me go ahead and redraw that for you. Right, so here's our 60 and our 8 square root of 3 that we know, and we just concluded this was a 4 square root of 3. that we have across from the 30-degree angle, right? That's going to be our star. So this A, that altitude that I still need to know. What do you do to go from the star around to the long leg that's across from 60? That's where we multiply by the square root of 3. So you're thinking 4 square root of 3 times square root of 3. So that's 4 times the square root of 9, which is actually 4 times 3, which would be 12. So your altitude then is 12. The next question in here at 23, the length of a diagonal on a square is 22. So draw yourself a square where you know all four sides are congruent. The diagonal for it is 22 units. So what's the length of each side? Well, remember the square does have that right angle, and it does have those congruent sides, which would also mean that it now has these congruent angles. So you're talking about a 45, 45, 90 triangle here to focus on. So with that 22 as my hypotenuse, what do you do to come around to a leg on at 45, 45, 90? We divide to get to a smaller leg, divide by the square root of 2. So what is 22 divided by the square root of 2? This is going to be an excellent chance for you to rationalize the denominator. Multiply by a square root of 2 over a square root of 2. We're talking about 22 times the square root of 2 divided by 2. And notice we're going to have to simplify that fraction. What's 22 divided by 2? You're left with 11 times the square root of 2 for your side lengths. In 24 here, the perimeter of a rectangle is 32 feet. So let's get this rectangle in here with a perimeter of 32 feet. And it's going to have a length and a width. The length is 3 times as long as the width. Length is 3 times as long as the width that we're given it. So 3 times the width. Calculate the length of that diagonal. So first of all, let's find out what this length and that width are, certainly. So remember that perimeter is 2 times the length plus 2 times the width for that. So 32 is going to be equal to 2 times 3w plus 2w. So if 32 is equal to, let's see then, 6w plus 2w makes 8w. So the width is equal to 4. So plugging that in, width is equal to 4. Length is now 3 times that 4, which would be 12. So using that, we're going to find the length of the diagonal now. So let's focus on the right triangle with a length of 4 and a length of 12. Obviously not drawn to scale again in Mrs. Spencer's world, but that's okay. To find that diagonal, I now know two sides, 12 squared plus 4 squared, so we can find the diagonal squared. So let's see, 12 squared plus 4 squared puts me at 160, equal to my diagonal squared. We will have to take the square root on both sides to cancel that exponent. So when I go ahead and write down that diagonal information, let's try to simplify that radical. 160 would be a 16 times a 10. 16 is 4 times 4. 4 is 2 times 2. 4 is 2 times 2. These are all prime. 10 is a 2 times a 5, and those are both prime. So a pair of 2's and a pair of 2's gives me a 4 out front when I multiply those, times the square root of 10 from that 2 times that 5, still within the diagonal, is 4 times the square root of 10. And then on to 25. From the top of a 210-foot tall lighthouse, let's get that drawn. The angle of depression to a boat is 27 degrees. Here is our boat. So remember now, you have to look straight out at the horizontal and then drop your line of sight to get the angle of depression as that 27 degrees. Now, the angle of depression does match the angle of elevation from what the person in the boat also looks up to see the top of the lighthouse. Find the distance from the boat to the base of the lighthouse. That is my missing measurement. So from that angle of elevation, that'll be my reference angle. 220 is my opposite. The distance that I'm looking for, D, is my adjacent. that's going to need a tangent function for us. So if we set up the tangent of 27 is equal to the opposite over the adjacent number in the angle, put it over a number 1, and we'll go ahead and cross multiply. 210 times 1 makes 210. Tangent of 27 gets multiplied by d. We're going to divide both sides by that tangent of 27 so that we can cancel and isolate the variable. And so just merely leaving it up to our calculator now. 210 divided by the tangent of 27. So here we are. I'm running out of room. The distance is 412.15 feet for us. Just over 412 feet from the boat to the lighthouse. Next up here, Pedro has a square practice net in his backyard. So here's his square with 4 congruent sides. The diagonal is given to us as 6 feet. Find the length of one of the sides. Well, again, it was a square, so I know I have a right angle, and the diagonal is going to intersect that. If I have got the 2 congruent sides, I've also got 2 congruent angles. So it's now a 45, 45, 90 triangle. From that hypotenuse to get to a side, we have to divide by the square root of 2. So what's 6 divided by the square root of 2? Here we go, rationalizing that denominator again. Multiply by the square root of 2 over the square root of 2. And across the numerator, that'll be 6 square root of 2. Across the denominator, square root of 2 times square root of 2 makes 2. Go ahead and simplify your fraction. 6 divided by 2 makes it 3 square root of 2 feet for us. 3 square root of 2 feet. And on to that last page. 27 here wants us to find the value of x. This x is an angle, so that's going to require us to do some inverse trig. Label the sides that you have all the way across where I find the opposite, and away from my right angle, we find the hypotenuse. So you're thinking about the sine here. Now, don't let the fact that this had a square root in the problem trip you up into thinking it has to be a special right triangle problem. That's not what we're given here. I'm trying to find an angle, so that has to be an inverse trig, unless you immediately recognize that those side lengths follow a special right pattern. So the sine of x then has to be the opposite over the hypotenuse. So it's 3 over the square root of 58. So to find the angle, you are doing inverse trig, which means that I'm going to use the functions on my keypad. All the inverses show up with the -1 notation on that calculator. So inverse sine, type in that fraction. It's 3 divided by the square root of 58 for my fraction. And we're talking then about my x value being 23.198, which would actually then round up to 0.2. This actually even says go ahead round to the nearest degree, so x would be 23 degrees for us. Now, 28 wants you to find the values of x. These 4 problems are actually just asking how well you can use the trig buttons on your calculator. Okay, so part A wants the sine of 42. So we put that in, rounding to the nearest hundredth. That's 2 decimal places, so 0.67 for us, because the third position is a 9, so it's going to round that 6 up to a 7. Part B wants the cosine of x when it's equal to 0.43. So if you're looking for x, you're looking for the reference angle. That's telling you to do an inverse. So what am I doing here? An inverse cosine then of 0.43. So you're not typing in a fraction this time, you're typing in a decimal. That tells me that x must be equal to 64.53. So this angle about 64.5 degrees. Tangent of x equals 37. Again, x is my reference angle, so I'm doing an inverse problem. Under my functions menu, choose from the middle column where I see my function with a -1. So the tangent of -1 is 37, and there we go. Find that x value now. This is 88.45 degrees for us. Part D wants the tangent of 87 to be equal to x, so I'm looking for what that number is when I put in the tangent of 87 it will give me out my value. So x then is approximately 19.08. And there we are. We put those values right into our calculator. 29 then is going to have us writing some ratios for the sine of A and cosine of A. Based on angle A, that's my reference angle, so sine is going to be the opposite over the hypotenuse. So the sine of A is 35 over 37. Then the cosine of A, we know cosine from the same reference angle is adjacent over hypotenuse. So that will have to be 12 over 37. There we are. Now number 30 for us. If the tangent of A is equal to 5 over 8 in right triangle ABC, find some ratios. So I'm going to draw the sketch for my triangle ABC. And A is the reference angle. So 5 is my opposite and 8 is my adjacent. So from angle A, label my opposite as 5, label my adjacent as 8, which means that to find sine and cosine, I know both of those involve a hypotenuse, so I need to figure out what is this hypotenuse measurement for us here. Well, let's see, Pythagorean theorem, 8 squared plus 5 squared equals that missing hypotenuse squared. So let's see, 8 squared and plus 5 squared, going to put us at 89 equal to h squared. Take the square root on both sides, and let's see here, can we make a factor tree for square root of 89? And 89 is not going to be able to make that into any simplest form. So the hypotenuse is the square root of 89. So using that now, step to the next item, take the sine of A. So sine is opposite over hypotenuse. So the opposite from my angle A is 5. The hypotenuse is the square root of 89. Time to rationalize that denominator. So I'm going to multiply by square root of 89 over square root of 89. What's that look like for us now? Let's see, across the numerator, 5 times the square root of 89. Across the denominator, square root of 89 times square root of 89. Well, any value squared. There we are. Square root times square root cancels. So here is the sine of A. The next item wants the cosine of A. So cosine is adjacent over hypotenuse. From angle A, my adjacent is the 8. My hypotenuse is the square root of 89. Again, we need to rationalize that denominator times the square root of 89 over square root of 89 so that we can remove the radicals from that denominator. So 8 times the square root of 89 over 89 is our cosine of A ratio. Now, question 31 talks about this kite that is flying in the air. Let's make a sketch for us. Okay. So here we have our kite flying at an angle of elevation of 40 degrees. When 80 yards of string has been let out, how high is the kite flying above the ground? That's what we don't know. So I'm going to go ahead and make that into, as you can see here, given an angle, looking for a side. When we know a side, that's going to be a trig problem. So I have an opposite and I have a hypotenuse. This will be a sine. So we're doing the sine of 40 is equal to x over 80. Number in the angle, put it over a number 1, cross multiply. X times 1 is x. And then we'll do the sine of 40 times the 80. X is already alone. You're just asking your calculator to do some work for us. So the sine of 40 needs to be multiplied by that 80. So x is 51.42. There we are. We're talking about 51.42 yards above the ground for our kite. In 32 here, nice time to talk about Carl the Carpenter. His ladder is leaning against a wall at a height of 21 feet, okay? So here is his ladder, and it touches the wall 21 feet above the ground. We know that this ladder is 2.5 feet away from the wall. Again, we're going to assume that the ground and the wall make a right angle with each other. So what's the angle that the ladder forms with the wall? What is this angle where the ladder and the wall come together? Looking for an angle, this is going to be an inverse problem. So label what we have. 2.5 is opposite from my angle. 21 is the adjacent leg with my angle. That's going to be a tangent. So tangent of x is equal to an opposite 2.5 over an adjacent of 21. So looking for that angle, this is an inverse. In my functions, choose that inverse tangent with the -1 notation. Type in what I'm doing the ratio of, 2.5 over 21. So my angle must be about 6.79 degrees when you round that. Oops, this one even said round to the nearest tenth there, so I'd better erase a little bit. Right, and so for the nearest tenth, that would just be one decimal place. So I'm talking about 6.8 degrees then for us. Last question here. A 12-foot tall lamppost. Okay, here's our lamppost. Casts a shadow at 4 o'clock in the afternoon. The angle of elevation of the sun is 42 degrees, right? So from the ground, we look up at 42 degrees to see past the light post to the sunshine, right? It's continuing along this same path for us. That line of sight continues along to see the sunshine up there, okay? So that's why we have this angle of elevation 42 degrees. We've got it so that we are finding the length of the shadow. That's what I need to know. And it was a 12-foot tall lamppost. So using that information, I hope you see that this is going to be a tangent setup. Tangent of 42 is equal to opposite over adjacent. My opposite there is the 12, and my adjacent leg is the x that we are trying to find about. Number in the angle, put it over a number 1. Cross multiply, 12 times 1 is 12. Cross multiply, tangent of 42 is multiplied by x. We are going to have to divide by that tangent of 42. And what you divide on one side, you have to divide on the other side. So anything divided by itself cancels. We've got x alone, and we're asking our calculator to do some division for us. 12 divided by the tangent of 42. I'm going to get 13.33 when I round that off. So 13.33 feet tall for the lamppost. I hope you're feeling a lot more comfortable now with solving your right triangles and that you are readily able to determine whether you should use Pythagorean or trigonometry or special right triangles in order to solve. Have a fantastic day.